and I'm really excited to talk to you today about how you can be a data PM without actually being technical in kind of the original sense of coding or writing lines of SQL, for example. A bit about me before we jump into it. I studied electrical engineering and computer science at Berkeley back in the day, and I thought I was going to be a software engineer for a while until I realized that was not for me. I found products at eBay. I worked at eBay as their ranking PM. So basically, given the billions of items that are on eBay at any given time, and given the hundreds of millions of people who may want to buy something at any given time, how do we show the best item to them to make that connection work? Then I came out to London. I worked at Just Eat, and I was on, again, in the data organization, so I can talk about my experience there. And then now I'm at Facebook, and I'm also, again, kind of in the ranking sphere. So again, using machine learning to make sense of billions of items of data. Quickly, a bit about me, but from a fun perspective, I'm originally from California. I spent around 7 years in Silicon Valley. Moved out to London a little less than 2 years ago. And I'm a big fan of basketball, so I took a picture of myself playing last weekend. Okay, before we jump into how you can be a data PM, I thought it's a good place to start to say, why do you want to be a data PM and why is data important? So the context for today, you may have seen this, a lot of people believe that big data and AI will actually be the fourth industrial revolution, on par with at least as large in terms of impact as any of these industrial revolutions before them. And the reason being, let me take you through just one example that you can extrapolate and think through other types of applications like this. But I'll take you through one example of how large of an impact data and AI can have on our lives. So think right now how hard education is to get right for each individual student. Think how oftentimes if you don't have enough money to afford good education, you don't have access to it. Well, using AI that can be used towards personalization, picture a world where you could have your perfect coursework laid out for you, basically like a private tutor, and it could update automatically at all times and at scale to billions of people, basically whoever could access the internet. So that's just one application. I think that application specifically really excites me, and I think through how I want to get started in my career in data right now and in machine learning right now, and kind of set myself up to be in that industry in the fourth industrial revolution. So how do we actually get there? That was a bit sky is blue, but I guess the three things that we'll talk about in order to get towards being familiar with data and being a data PM will be, first, you need to know how to set the right goals for your company or your team in order to make sure you're heading in the right direction. Once you've got those goals, then you need to have the right metrics so that you can track and know that you're going in the right direction towards those goals. Then, once you've got that all set, you need to be able to understand if the projects that you're working on are the right ones, and so you need a testing structure. For there, I'll lean heavily on examples. And then third, we'll talk through prioritization and trade-offs from a data perspective. All right, so jumping into how do you set a good goal. I think the point of a goal is, as I said, to make sure that you're working on the right thing and you're going in the right direction. And one really important piece of that is that you're one piece in the part of your larger organization and, in fact, in part of your larger industry. And so you really need to think through, where does your company want to be in 2 years, in 5 years, and in 10 years? And given that context, then you can decide how you want to play a part in that. I'll give an example. If you're working on a startup that has pretty good funding, then there's not really any point in optimizing for revenue when you should be looking towards just maximizing growth for your users so that your company can kind of accelerate. The next point is it needs to be measurable and quantitative very quickly, a quick feedback loop as well. So an example there would be maybe you want to use user satisfaction, but that's actually quite hard to measure in real time and be able to iterate and pivot based on. So maybe a better metric would be something that you can aggregate in real time. It also needs to be ambitious. So you should ask your team, what do you think you guys can reach in a year's time? And then you should multiply it by 1.3 or something like that. And that really pushes your team to go beyond their comfort zones. And then lastly, it should motivate people to come to work every day. I really like this example from eBay, which was eBay could have really focused on eBay revenue, and we could have tried to make eBay a more profitable corporation. But instead, we focused on making money for the sellers who are on our platform. So the businesses who are trying to make a living on eBay were the people that we focused on trying to increase their businesses. And that did two things. The first thing is it really inspired us to work harder and try to push projects that increased revenue for them. The second thing it did was force us to really think through what's best for the seller rather than what's best for eBay. And so that really affected what kind of projects we've done. So now that you've got your top line goal and you understand what's important to you, there are a couple of metrics that I think are important to pay attention to. The first is a class of metrics called counter metrics. I really like this. This is a really good thought process for product managers to do in order to make sure, I guess the scenario is like, let's say you're tracking really well against your top line goal. So you're doing really well in terms of, let's say it's revenue. What could still go wrong for your team? And if product people can get themselves in this type of mindset and doing this type of like framework thinking all the time, then that way you can think through all of your edge cases and you won't be surprised when, I guess, things turn kind of sour. So I'll go through an example now of how you can think through counter metrics in order to do this thought process. So let's take the example, again, keep the marketplace theme going. Say you're a marketplace. What could go wrong even if you're continually improving revenue all the time? And so you're launching changes that are positive for your revenue. The first is, let's say you've got types of listings that are promoted. So for example, you have to pay extra money to have these types of promoted listings. You could have a quick kind of hacky way to increase revenue by just increasing the percentage of those that you show and that sell. That would be, in the short term, through testing, that would look positive in terms of revenue. But actually in the long term, that could lead to a loss because users can engage with that type of listing less excitedly and over time would come to your platform less often. It's important to realize though that A/B tests would recommend the wrong short-term move here. And so this is where a counter metric could come in handy, where your top line goal is revenue, but you could have a counter metric that said, let's make sure that our ratio between paid listings and organic listings is the right ratio. So it's something that you track alongside your top line goal. Another example would be, you could be launching revenue improvements that overall, if you look at your total revenue, look pretty good. But if you break it down by subset, you see that you're actually only helping one subset of businesses over time. So take, for example, let's say Target was selling on your platform, and you're helping lots of companies like Target to get incrementally bigger, but you're actually kind of suffocating all of the smaller businesses that are just trying to make a living on your platform and trying to grow. And that would stifle the pipeline where people would start as small and then grow into these large businesses, which would, over time, be bad for your marketplace. So this is another example of a counter metric where you track revenue as your top line goal, but you pay attention to each of the distributions, so each subset of types of businesses on your platform. And the next one is, you could, and I see this all the time at big companies, I think people are incentivized to over-index on short-term gains. So the problem here is that if you ask people to track their improvements towards your top-line goal, then one of the issues is people will try to do something that they can see measurably in a month or 2 months or 3 months. And so a way to make sure that you have a balanced portfolio of projects is, again, you could have a counter metrics on your portfolio that says you need a certain amount of projects that are either high risk or not expected to see reward for whatever it is, 6 months or a year. And then the last one, for example, you could have items that are inappropriate or illegal. For example, you could sell alcohol to minors, and that would probably sell pretty well. But this is obviously not something that you want to do. It's bad for society, and it's also bad for your public image. So again, you could have a counter metric on this, that you're not allowed to increase inappropriate or illegal items. There's tons of other thought processes that you can run through for a marketplace, but I think this is, as I said, a good thought exercise for product people to be keeping their team focused on not just this top line thing, but also what is everything else that matters to our ecosystem of our product. So we've talked through high-level goals, then we've talked through counter metrics to make sure that we're tracking in the right direction. The last type of metric I want to talk about, I call proxy metrics, and they're really useful for prioritization. So essentially what they are is they're a bunch of different metrics that roll up into your top line metric, and they allow you to focus on a different part of the product while still driving your top line goal. I'll run through an example if that was confusing. So take, for example, you're a website with job postings, so you could be LinkedIn or read.co.uk, and you're trying to basically connect job seekers with people who are posting jobs and have open vacancies. Let's say, again, your top line metric is revenue. How do you decide if you want to prioritize decreasing sign-up time for the job seeker, so someone who's searching for a job, decreasing the amount of time it takes them to find that job, or decreasing recruiter time, so the amount of time it takes people to post jobs. And at first this could be kind of a confusing problem, but proxy metrics can actually really help us with prioritization here. So one way to do this is to find, as I said, take your proxy metrics and roll them up to your North Star or top line metric. So here, we can basically take decreasing time to sign up by W minutes, and we can convert that and understand the relationship between decreasing the time to sign up and how many more job seekers we would get on our platform. Then we can understand the relationship between having more people on our platform looking for jobs and how that affects recruiters who come on and basically list jobs. And obviously there's a relationship between listing jobs and revenue, because I think a lot of these platforms will charge people to list jobs. So that has a direct relationship with revenue as well. You can do the exact same thing for the job poster side, where you try to understand the relationship between decreasing the minutes for the recruiter to time with how many more listings that they can create. And then again, how many listings they can create directly affects revenue. So then it becomes quite easy, because then you can actually just compare the revenue from either side of that equation. I think the part that's missing, you might wonder, is how do you decide this relationship? How do you understand the relationship between the time to sign up and how many more job seekers you get? And how do you decide, given more job seekers, how many more paid listings that's going to produce? There's a few ways. I think the main ways that you can look at are you can run A/B tests. So and I'll go actually in the next slide on what that is if you don't know what it is. But you can basically do tests and simulations to see what would happen if you decrease your time to sign up, or if you increase your time to sign up. What does that curve look like? And then you can actually extrapolate it and try to understand what would happen if you made further improvements. The other thing that you can do is look at historical tests. So in the past, you might have had experiments that improved sign-up time or improved recruiter time. And you should look at the results, the impact that had down funnel at your top line metric. So that seems sort of simple, I guess. You just take two things and you join them into one same metric in order to be able to compare them, and then you just choose whichever one looks better. I think we should caveat this though with you can't actually just look at this almost in a vacuum. You actually need to look at it in terms of the long-term strategy of your company or your team. And I think this is where product people can have a very large influence, because product people are able to really think through what is that long-term strategy, where do we want to be in 2 years and 5 years, and not necessarily just crunch the numbers, but actually think of it in the wider context. So an example that kind of caveats the previous example was, what if you had 3 times as many job seekers as you have job postings? Then actually you shouldn't just crunch these numbers and choose whichever one. You should probably actually triage, why do you have so few job postings, and how can we make the experience better for job posters? And that would be an example of looking at the data and fitting that in with your long-term strategy, rather than just kind of blankly taking the numbers. I'll give 3 more examples of how the long-term strategy can affect the numbers and kind of change the way that the equation looks. The first is, you could, let's say you're a marketplace, again, this thread, and you're continually launching things that are revenue positive. And so these things look like they're doing a really good thing for your business. But actually, if you broke it down, you could see that you're decreasing the price or maybe the quality of the listings that you're selling. Maybe you find that cheaper things sell. And so in the short term, that looks like it's a good thing because you're increasing revenue. But actually, as a long-term strategy, you should probably take a step back and think, we don't want to look like a cheap marketplace. We don't want to look like a wholesale place. And so that's where, again, the long-term strategy affects prioritization decisions. The second example, I already talked about this, but just putting it again here in this context, is you can saturate your market if you don't align it with some kind of long-term strategy. So again, don't just take examples of which one looks like it'll have more impact on your top line metric. Instead, look at the impact that it'll have on your marketplace over time as well. And then lastly, you might, I guess one example of this is, let's say you've never run a personalization, you've never done any personalization projects at all. And you're weighing a personalization project with some other project, and it looks like the other project is probably going to produce more revenue. In fact, you might actually want to run the personalization one so that you can have the knowledge of how does personalization in general work on your customer base. Then that allows you to think through in the future, while you're deciding which project you want to do, you'll be able to pull back to your knowledge from that A/B test or that test that you ran on the personalization project. And that'll help you make decisions on prioritization going forward. Okay, so we've talked through, you've got your top line metric, and it's in the context of where you want to go and what your long-term strategy is. And then you've got different types of metrics that can help you get there and can make sure that you're trending along the right direction, given your product context. Now, I think the next step is A/B testing. So for those of you who don't know, A/B testing is a really good way to understand if one thing is better than another thing, and you can try to isolate like a given product feature and see if it's better in a certain way or another way. So the way that it works is you take some percentage of your audience, let's say 50%, and you show them one variant. Then you take the rest of the audience and you show them another variant, and you just count the number of events that happen on each in each variant. And so, for example, in this one, if you were counting conversions, you could see that variant A had 23, variant B had 11 conversions. Can you raise your hand if you think variant A is better than variant B? Okay, maybe. Basically, the issue with this is that A/B tests always need to have a confidence interval associated with them. And so this may be better than variant B, but actually maybe it won't. The problem is, for example, you could have had 100 visitors total, and maybe 50 of them saw this, and 50 saw this, and 23 divided by 2 saw this, and are converted, and 11 divided by 2 converted here. And so actually, without a confidence interval, you aren't able to say that this, with any surety, was better than the other experience. And just to highlight that a little bit further, this is why A/B testing is important. Essentially what we're seeing here is that as temperatures have increased over time, the number of pirates has also approximately gone to 0. So without A/B testing, we wouldn't be able to tell, or we might surmise that actually we just need to bring the pirates back in order to stop global warming.
Eureka.
Yeah, exactly. Great. So I'll go through a few A/B testing principles, and then I'll talk through 2 examples of where product managers can really add a lot of value in terms of A/B testing. So the first is you should A/B test at least for a week. The reason being, your different customers could act differently. Your customers could act differently on different days of the week. So for example, if weekends are really important to you, then your customers may act differently on weekends than weekdays, and you want to make sure you represent that entire cycle. Similar type of reasoning, seasonality could play a difference. So for example, if you are a merchant who does shipping and you test something right before Christmas, then maybe shipping is a lot more important than it actually would be throughout the rest of the year. So you need to pay attention to seasonality as well. Confidence intervals are interesting. We just talked about them, the pirates. And I guess the reason, so a confidence interval is basically at what threshold are you going to say that we think this thing is better than this thing? And you could choose something low, or we'll start with something high. You could choose something high, like 95%, and that would mean even if you get something that is 90% confident is better than the other thing, we're going to throw it out and we're not going to pay attention to it because we're only going to trust it if we're 95% confident that it actually is better. The reason that you would do 95 versus something like 80 is if you don't, well, the reason you would do something like 80, which is slightly smaller, is if you don't really mind taking a bit of tech debt, so technical debt where you're accruing things in your tech stack that actually might not be making an impact to the overall system. You don't really mind that as much. Maybe you're a smaller startup and you really want to move quickly and you don't really mind picking up a bit of tech debt on the way. On the other hand, maybe you pick 95 because you have this huge complicated tech stack. Maybe you're a large company that already has pretty industry-leading, I guess, a station in the industry where you're pretty comfortable, and maybe you want to make sure that the things that you're launching definitely are better for the customer. All right, great. So let's jump into 2 examples. So given those principles, now we can set up our A/B tests. And the examples I wanted to run through here, you've probably heard about a minimum viable product, which is essentially trying to build the smallest thing that you can in order to go to market as quickly as possible for your customer, and then iterating on that after you can get feedback back from the customer. And so I think one of the places that product managers can have a lot of influence is definitely in this space, where it's quite common for people on an engineering team, for example, to get really excited about building something really intricate and really cool, when product people need to kind of have them take a step back and think, actually, what's best for the customer, and how can we build something as quickly as possible and keep testing our idea. And I think this is especially important in the data and AI space because it is such a complex space, and you can very easily jump to just building machine learning models for everything. So I've got 3 examples here of how you don't actually need to build a machine learning model to do pretty well without all of that technical work. So the first is, let's say you've got an app and you want to build voice interaction with your app. So you want to be able to talk to your app rather than having to type. The first thing that you could do to find out, is this a good idea, is you could start by putting a microphone on your app that actually gets people's kind of opinion. If they're clicking on this microphone, are they even interested in the first place to being able to talk to the app? So you can gather all that data, see how much people are interested in it. Then if you decide, you know what, it is worth going forward, let's do this, then you could manually parse the top queries, however many queries you want to parse, and you could group them by synonym. I'll give an example of what I mean here. Let's say that you can order things through your app. Then you can group words, like you can group buy, you can group order, you can group, I don't know, whatever other synonyms for that. And then you can look at all of the things that people say on your app, and if the majority of them are in the same group, so let's say like 80% of the things that people do on your app fit into 500 different commands, then you could actually just build these as like, if this is the command, then do this. If this is the command, do this. And that's so much simpler than actually building an entire voice interaction where you have to be able to parse language and come up with understanding and natural language processing and all of that. So this would be an example of where a product manager would probably come in and say, hey guys, let's take a step back and think how we can build something a little bit less complex to start. And then quickly, another example would be if you're developing, like for example, Gmail. Example areas for machine learning here would be, you could identify if someone has forgotten an attachment. I think this is something that they do now. And you know, it's kind of annoying when you go to attach something and you say, this thing is attached, and you completely forgot it, and you click send. And so you want to tell them, hey, you forgot an attachment. And you could start this by building a machine learning classifier that tries to predict if you meant to have an attachment and you don't, or something like that. But the alternative is you actually just parse the text and search for the word attach, or attachment, or attached. And that would be maybe a day's work rather than like 3 months of work. And same thing with auto-generating a calendar invite. You might want to generate a calendar invite if you think that 2 people are trying to set something up with each other. And instead of, again, building a classifier that tries to detect if people want to meet up, you could just parse the email content for like the date or the words meet up or catch up or something like that. Great, so that's kind of it on A/B testing. So to recap, we've talked through, you've got your top line goal, you've got metrics to make sure that you're on track to building the right product, and then you've got a great way to test as quickly as possible in order to, again, build the right products and make sure that you are iterating on the stuff that you build. The next section, and this is the last section, it's kind of the meaty one, is on how do you do trade-off decisions. And what I want to highlight in this section is there's 2 things. The first thing is I want to help think through how can you collect the right data in order to make the right trade-off decisions. And so it's not about actually writing the SQL queries, it's knowing what are the right data points that we need in order to make the trade-off decisions. And the second thing is I want to highlight, again, how product can be especially helpful in this scenario. So beyond just the data part where you're knowing which numbers to crunch, there's actually a really important part for product people to play beyond the data. So, that's what I'm saying here. Yeah, so knowing which data to pull to make the decision, as well as bringing the customer into the decision. All right, so I've got an example, and this is quite a extreme version of this example, but I want to highlight again how product people can bring a different perspective to these problems. So let's say that you're releasing an autonomous car product. How many people would you allow to die while they're using your product? At first, you probably think none. You don't want anyone to die using your product, and you don't want that on your hands. You're not releasing a product that does that. But then you think, actually, we just need to be better than the baseline, where the baseline would be the average driver. And then think of all the lives that we're saving if we're better than the average person who's out on the road right now. Think how many lives we're saving because we're not making the same mistakes that people make. But I think this is the interesting one where actually product people really can have good input. Actually, imagine that the media and public perception aren't ready for autonomous cars yet. And even though you're better than the baseline, you're not good enough. And people are outraged, and there's bad media coverage, and then your growth stagnates, and actually your business kind of plummets. Now think of all the people who are dying because your car product didn't make it into the market, and people are still driving and still making the same mistakes. And so this is, again, kind of the contrast where a data PM needs to be familiar with data, but also needs to be very familiar with the public perception, the media, the effect on the customer, and we can actually bring in kind of a separate opinion that's not entirely data focused, it's also bringing in the personal element to it as well. And then just one more highlighting kind of the same thing is kind of a similar use case. Let's say you are in charge of the UK traffic lights, and you have to decide how long do you put between a red light and a green light. And you can imagine if you make that time period between red and green small, then it saves people a lot of time. That's a lot of time that they could be working or spending time with their family. You're also saving on pollution. There are fewer cars on the road, less traffic. But on the flip side, you're probably increasing the number of accidents if people are quickly going from red to green. So in order to solve this problem, how do you even start solving this problem? And this is, I guess, a generalizable problem, and this is just one example of a way to tackle it. The first thing that you can do is you can visualize that trade-off. So you could have accidents per year or deaths per year in the y-axis, and you can draw this ratio where as you change time from 1 second to 2 seconds to 3 seconds, how many people are we affecting and what are the accidents? And what you can do once you've graphed this is you can find the inflection point where you stop seeing as much return. So the rate of return heavily decreases. And I'd say that would be around here, where between 2 and 3, and if this were a real graph, it would be kind of noisy. There would be like a bit of this going on. And so between 2 and 3, after 3, you probably don't see much of a return from this. So the first step, as I said, is graph the trade-off, then find the inflection point, then find 2 points that represent the conservative but expensive solution and the riskier, faster moving one. So that would probably be 2 seconds here and this many deaths, and 3 seconds here and this many deaths. And then with these that represent your 2 extremes, you can test them in isolated markets. And that way you could actually see the full ecosystem effect of what your decision is. You can actually study in the different markets what is the effect of your product choice. You can extrapolate this example to any type of problem where you are able to graph it out and find an inflection point and do testing. So I've got 2 more examples on making trade-off decisions, and that's it for today. The first is building kind of like a spam classifier. And I think the point I want to highlight here is that there are a lot of different data points that you can bring in order to make decisions on machine learning products or on data products. So this is an example of a data product where product people can have a lot of influence in what we build and what trade-off decisions we make. So the trade-off that we're grappling with is how much do people care about losing an email in their spam folder versus how much do they care about seeing extra spam? And if this is the question that you're supposed to answer and you're supposed to decide basically how much of these levers matter to people. And I guess, actually, I'll take a step back. The trade-off is basically you're never going to build a perfect classifier. In an ideal world, you would know exactly if something was spam or if it wasn't spam. If it was spam, you would remove it. If it wasn't spam, you would leave it. Unfortunately, we aren't that good at classification. And we're going to make errors somewhere. And we can decide if we want to make error by letting emails that are spam sneak into the inbox or letting more emails that are not spam get filtered out. And so this is where the product person can have opinions in which one is more important to their users on the email platform. So, got a bunch of data points that I want to help people just think through that could be really interesting if you're trying to make this trade-off decision. The first two, and these are very common if you're looking at any classification problem in machine learning or, machine learning. The first is precision. So it essentially means of all the emails that we've classified as spam, what percentage were actually spam? So, yeah, exactly. And then there's recall. Of all the spam emails that are out there, what percentage have we actually accurately classified as spam? And so you can see if you increase your precision, and so you're correctly, when you do classify something as spam, you're correct about it. That's what precision is. If you're increasing that, you probably decrease your recall, where you're probably missing out on some of the spam that exists out there and you're not catching it. And vice versa, if you make your recall better, you probably make your precision worse. And so these are good data points to have, and you can actually graph your precision and recall and be able to understand, as you get better at precision, how much worse do you get at recall? And as you get better at recall, how much worse do you get at precision? That then also allows you to kind of find an inflection point, like we just talked about on the past page. But beyond precision and recall, and these are things that if you work on a data product, people would be very savvy with, so not exactly the point where product people can have the best influence. But product people can have a really good influence in deciding what other points of data do we need to make this decision. So additional data that you can grab. First is, how often do people check their spam folders? This is interesting because imagine that people check their spam folders once a week. Then it probably doesn't matter if things get put into their spam folder because they'll find it there anyways, and they won't actually miss out on any good content. But on the flip side, if they never check their spam folders, then it's pretty important if they lose something important. And also it's important not just to look at what happens on average, because also let's say on average people check once a week, but the 30% of your users only check it once a year. And so for those 30% of people, it would actually really, really matter if they lost some of their emails into spam. And so again, this is one of the data points that you would want to grab in order to make this decision of this trade-off. The second is, for non-spam email in the inbox, what's the likelihood that it's important? Because maybe the relative importance of your spam and your email in your inbox actually isn't that different anyway, and we can get more spam into your inbox. The third is, for all of the spam in your inbox, how quickly do people unsubscribe? And I think this is interesting because let's say that your spam, like every time you get a spam email, you just click on it and you unsubscribe. It takes you 10 seconds, and it doesn't matter anymore ever again that you got that spam email. That helps you quantify what the negative effect is on people for seeing spam. And lastly, for the spam email in your inbox, what's the negative impact on the perception of the email engine? And that really helps you to quantify how big of a deal it is, again, when people are seeing your spam. So the last, kind of tying it all together, this is an example from my experience actually at eBay, is in order to highlight this example, this is the last example again, I need to explain kind of what I did. So my team was basically given a query, which here would be iPhone. We decided what these items were. And again, we kind of had to pull that from all the available items and then try to understand what would probably sell the most. And the issue that we kept getting was that was this relevance issue where you type in iPhone and you expect to see iPhones. But unfortunately, we're grabbing everything with the word iPhone in the title, or sometimes even just in the description. And then if you sort from lowest price, then all of the accessories are going to come up above the iPhone itself. And so these pages are just flooded and flooded. I don't know if you guys have seen this on eBay or Amazon or Walmart. But this is a really tough problem to tackle because first you need to know what the query means. And it's hard for an algorithm to know what a query means. Then it's really hard to identify each and every one of these, what actually is it, and then you have to actually match them. So let's see. And the other interesting thing is that it actually has, we believe, a long-term correlation with revenue. You would think, right? Because you'd think it would be a better user experience for people to be able to type something in and then see what it is that they're looking for on the page. But we actually found that it oftentimes has a short-term negative correlation, and the reason is that cheap things sell. And so cheap things oftentimes will show up instead of the expensive thing. Like, I guess you could think, in the iPhone example, we sell a lot more accessories than we do actual iPhones. So, quick crash course on how you could solve this problem. How do you do machine learning classification? Basically, the long and the short of it is, you just need a bunch of examples of what relevant is and what irrelevant is. So you'd have a bunch of these pages where you'd have a query and then you'd have an item. And you would say, this is irrelevant. This is irrelevant. And then you'd have some examples where it's relevant. And you need like millions of those examples. Then you write features that could help to determine if it's relevant or not. So these would be the engineers would go write these, and they would maybe bring in the title, and they would say, given this title, is this title like relevant to this query or not? Is this price relevant to this query or not? Is this in the right category, do we think? And you can give it a bunch of, basically you're giving it a bunch of data points to make a decision on whether it's relevant or not. And then the last thing you can do is you train and validate your model on the data. So given all of these examples, given all of these features that might make it relevant or not, now we can actually build a machine learning model that decides, given a new thing, is it relevant or not. So this is actually a pretty solvable problem if you have many, many examples of what relevant and irrelevant is. But how do you get that? How do you get examples of relevant items? And that is definitely the crux of the challenging problem. And this is, I'll talk through where I think product people can have good influence in a problem like this. The first step that we did was we defined what relevant and irrelevant were. So we essentially wrote a handbook that said this is relevant because of this, and this is irrelevant because of this. Then we hired and trained human labelers. So people who sat with, we'll go all the way back, people who sat with a query and an item and said this is relevant. Next query item, relevant. Next query item, irrelevant. And they did that millions of times. Then we optimized, so the interesting kind of crux of the product problem here is who do you hire and train for these human labelers? There's a bunch of different options that you could choose. You could hire very expensive, very well-trained people who are very accurate. So you can trust what they say, like 100%, no matter what they say. Or you could just kind of put it out to people who are just sitting around online, and they would be a lot cheaper. They could maybe 100x cheaper, but they would, and so they could do a lot more quantity, but their judgments would be a lot less accurate because they're less trained and they're less invested. It's not like their full-time job. And I guess the point I'm trying to highlight here is that while the machine learning engineers are the ones actually doing the modeling, the product people can be the ones who think through this problem of how do we get high quality data in order to feed into the machine learning models. And so I don't actually know what eBay is doing right now. We tried a bunch of different things, but one of the things that we tried, and I think this is kind of standard in this type of modeling, is you can go for quantity, but you can judge each query and item multiple times and only accept the judgment when to agree. So you basically get all of those people who are just on the internet, who are quite cheap, to do a lot of these judgments. And then you make them, so you'll give the same query and item pair to one person, give the same query item pair to another one. If they match, you take it in, and if they don't match, you don't take it in. And that allows you to get through a lot more judgments and have a lot higher quality. And then lastly, you can also have kind of a ground truth tiered system. So you can have really expensive judges that are, that 100x as expensive, but you trust them when they say something, and it's their full-time job. And these people provide a good infrastructure to understand how your quality is and be able to kind of iterate on it and see the quality and the price overall of what you're doing. So again, the point here is you don't actually have to write the code, you don't actually have to do the modeling, but you can help think through how to get good quality data, which I think is a good product problem. So again, this is I think overall this is a really important example of where PMs can add great value if they're savvy with data. So the first thing you can answer as a product person is this problem even worth solving? And again, to do that, we go back to our top line goal and we say, in the context of where eBay's trying to go, this is important. It's an important user experience. It's important for the company as a whole, even if it's not revenue positive in the short term. And then again, how can you trade this off with projects targeting revenue? You can either do the proxy metric thing where you relate something to a top-line goal, or you can think about it in the strategic point of view of the company. So again, it's an important thing to do for the long term. And then, again, we were just talking about this, so you don't actually have to be writing the code, but you can come up with the system and the strategy to get the best quality data to feed into models. That's a common thing for data people to be thinking through, even if you're not actually writing code. And then lastly, I think this is all just like a really exciting project work stream. All of the examples that I went through are all would not have been possible 10 or 20 years ago. And so I think it's just a really exciting time to be in big data and AI, and be in it for the fourth revolution, the industrial revolution. And lastly, just to wrap it up, so to be a data PM, it's not about knowing how to pull the data. It's not about knowing SQL queries or understanding like schema structures. It's about knowing what data is important to answer the questions that will help you build the best product for your customers. And for many trade-offs, we saw some pretty like hard, tough trade-offs. There are no right answers to determine very tough, to sometimes very tough problems. But aggregating data up front allows you to make the most informed decisions that can help you build the best products for your customers.